Okay. So we're getting into factoring. Some of you guys maybe remember this from Algebra 1. Judging by some of you guys' papers that I picked up, a lot of you guys don't, which is fine. That's why we're doing it. If I thought you guys all remembered this from Algebra 1, I would not waste our time today. So if you didn't know any of it, that's fine. That's okay. So we're starting with the most basic things, and we're working up to it. Now, there are some different times today where there are more than one way to do it. I don't care which way you do it. We'll talk about that when we get there. And I'll try to point out some small common mistakes some people make while we go through this. So the first thing I want to make sure you know is what is a factor. If I say 8 and 4 are factors of 32, what does that even mean? Now, most of you guys know what it is. And most of you guys, especially if I use that example, you could probably tell me. But just in case, the best way for me to describe it is if A is a factor of B, that means if you took B divided by A, you'd get a whole number. You wouldn't get a decimal or a fraction. There's another definition up there. There's a bunch of different definitions. I tried to pick one that is normal. Like if you look at your textbook, I think the definition is probably way worse than that. But the best way to describe it is to look at an example. So if 8 is a factor of 24, or is 8 a factor of 24, well, if you don't know, the way you do it is take 24 divided by 8. Is that a whole number? And most of you guys don't have to use your calculator. You know, oh yeah, 8 times 3 is 24, which means 8 is a factor. 24 divided by 8 is 3. That's a whole number, so 8 is a factor. Also, 3 is a factor, because 24 divided by 3 is 8. So if you divide it, you get a whole number. It's definitely a factor. However, is 8 a factor of 36? Well, if you take 36 divided by 8, you get 4.5. That means it is not a factor because you got a decimal or fraction when you divide it. So that is not a factor. So a lot of today we're going to go through and try to find factor pairs. We'll talk about that here in a second. And really, if I were you, I would just do a lot of dividing. 24 divided by 8, 24 divided by 7, 24 divided by 6. And go through and use your calculator. If you ever get a whole number, that means it is a factor. If it's a fraction or decimal, it is not. So one big part of today is finding factor pairs. So factor pairs are two numbers that multiply to be that original number. So for instance, that 24, I said 24 divided by 8 is 3. So 3 and 8 are a factor pair of 24 because 8 times 3 is 24. So there's a couple different ways to do this. And one way is literally looking at it and saying, oh yeah, 4 times 8 will work. Let's see what other ones. 1 times 32. If you were to do it that way, that's fine. I just was never good at that when I was in high school because I would always forget one of them. If I just sit and stare at it and try to think of it, I'd forget one. So I tried to come up with a more systematic approach. For some of you guys, it's going to take a little longer. But for a lot of you guys, it's going to be handy because you'll make sure you cover all your bases. You will not forget anything. So the way I do this is I make a little bracket. Zoom in here. So make a little bracket with my 32. And then I list all of the numbers that multiply to be 32, but I go in order. So I start with 1. 1 multiplied by what number is 32? Well, 1 times 32. And that's one that when people don't do it this way, a lot of people forget that one. And that's really an easy one. What about 2? Well, if you don't know, take 32 divided by 2. 32 divided by 2 is 16. So 2 times 16 is 32. What about 3? Again, if you don't know, put in your calculator. 32 divided by 3 is some decimal, so 3 doesn't work. What about 4? 32 divided by 4 is 8, so that's good. What about 5? 32 divided by 5 is a decimal. What about 6? 32 divided by 6 is a decimal. What about 7? 32 divided by 7 is a decimal. What about 8? Now here's the best part. This is why I like this method. You might tell yourself, oh my gosh, this is going to take forever. I have to try 1 through 32 and put them all in my calculator. No. All you have to do is try until you get to a number that you already have on your right, and then you're done. So we tried 1 worked and 2 worked. 3 didn't. We tried 4, it did work. Then we tried 5, 6, and 7. Now that we got to 8, and we already have that on the right-hand side, we're done. We don't have to try 9. We don't have to try 10 or 11 or 18 or anything like that. Once we get to a number that we have on the right, you don't have to try anymore. And that's one of the reasons I like this method. So those are all the factor pairs of 32. 18, same thing. We have 1 and 18. 2 and 9, 3 and 6. 4 doesn't work. 18 divided by 4 is a decimal. 5 doesn't work. 6 does. We already have 6, so now we're done. We don't have to try 7. We don't have to try 8. We can be done now. Now, some of yours will have one factor pair, like 7 is only 1 times 7. Some of them will have a lot of factor pairs. 270 obviously is a bigger number. It's going to have more factor pairs. So I tried to do this a little bit differently, and if we had more time, it would have worked out really nicely. But I'm going to have, these are the only two I'm going to have you do today on your own. Do these on your own, but don't do them on your notes. Do them on your cheat sheet. Here's the thing. I don't know if I said this already, but don't hold me to this. I genuinely have no idea. When I got to school today, compared to now, I already changed my whole philosophy on what the test was and what I'm going to test and how many things are going to be on there. So I obviously don't know a lot about what's going on with the test yet. However, it wouldn't surprise me, since it says cheat sheet, it wouldn't surprise me if we're going to let you guys use this on the test. Again, I'm not sure. Don't hold me to it. But I wouldn't be surprised that we'll let you use this kind of as a guiding or some notes on your test. So go to your cheat sheet. Go ahead and list those factor pairs. I'm going to give you guys a little bit of time to do that. All right, I'm going to go over a couple of these real quick, or I'm going to go over these two real quick. So 24 is one of my favorite ones because it seems like there's a lot. So 1 and 24, 2, 12. This is the one I always forget. 3 and 8. So again, I always use a calculator, and it helps me to go step by step because it seems like that's always the one. We used to use, there's a method of factoring called guess and check where you just guess numbers, and that seems like I'd always miss that one. And then 4 and 6. 5 doesn't work, and then you're back to 6, so you know you're done. 270, it's a big number, so there's going to be a lot of factors. Now, here's the thing. I know that's kind of a bummer, but doing it this way at least gives you a way that you're not going to miss any. And it takes a little bit of time, but yeah, it's a big number, so it's going to. So 270. 1 and 270. 2, I know 2 works, but I have to see what that one is. 2 and 135. I know 3 works. 3 and 90. 4 doesn't work. 5 should work. I don't think 6 works. Oh, 6 does. See, and that's one of them. I totally would have missed that one. I did not think 6 worked. 7 shouldn't work. 8 doesn't work. 9 should work. 10 and 27. Let's say 11, 12, 13, 14 don't work. And then 15 and, was it 18? So then try 16 and 17. They don't work. We're back to 18, so we're done. Now again, I know this process took some time. I get that. But if you do it this way, I know 18, that's a lot of numbers to plug in your calculator. Again, I totally sympathize. But if the number's 270, that's pretty good. All we had to do is try 18 numbers. So that's one of the reasons I like this method. And again, it's nice organized. You won't forget anything. Okay, so moving on. Now, since I have some extra time with you guys, I might actually do this. We'll see. But I'm always tempted. The problems we do today do not have this number in front. It's called the leading coefficient. Problems we do today won't have that. It makes them easier. But I'm always tempted to start out the harder ones because the problem is with the easier ones, it's nice to get some easier ones and to understand those. But then some of those habits you end up doing with the harder ones, and that's why some people miss them. And I'll talk about those in a second. But since you guys have about 15 minutes longer than other classes, I think, I might do this one with you guys just to show you kind of where we're headed and show you all these steps kind of in action. So there is several ways to solve these. Now, again, if you're one of those students that you either came from a different school or you had Algebra 1 at a different school or Algebra 1 on Apex, or if you just have a different way of doing this, that's fine. I may ask you to show me that way, and it's not because I don't believe you or I don't trust you or anything. It's because genuinely, I always am trying to find the easiest way to do this. And so if you have a different way that's easier, I want to see it because I might use that way, because I'm a thief like that. So this is the way I do it. It's kind of a combination of two. So I call it the X factor method or the X box. Originally, they used to draw a box around that, and I don't know why it was called X box. But if I were to say the X box factoring, this is what it means. You draw a big X. We'll talk about it in a second. And then I finish with divide, slide, bottoms up. Now, I'm going to be honest with you guys. I know that's what it was called here in Algebra 1, or else I think that's what it was called. I know the other Algebra 2 teacher, that's how she teaches it. I have no idea what divide and slide mean. The bottoms up part I know, and I know how to do that method, but I don't know the divide and slide. I know what that's referring to, but it's okay. I know how to do that method. Honestly, it's really funny because I like this really well. There are other schools that I've been at that will not teach it this way because it's just a trick, but it makes it insanely way more easy. So we're going to do it this way. We'll talk about it. It'll be good stuff. So before we even start with these 4 steps, 2 things I want to say. Well, one, I already said, if you have a different way of doing it, that's fine. Just make sure you show me your work. The other thing, if you keep track of your positives and negatives, it's really going to help you. And again, that's one of those things that I've gone back and forth on how to do the positives and negatives and how to make sure your signs are correct. And I think the easiest way is to make sure you keep track of your positives and negatives of your original equation. So, let's get started. First off, your quadratics that we factor using this are trinomials. There's 3 terms. You have an x squared, an x, and then a constant. The number with your x squared is always your a. The number with your x is your b. The constant is always your c. You guys remember this, or should remember it, from quadratic formula. If you don't, that's fine. We also do quadratic formula this chapter. So when I'm referring to a, b, and c, those are the numbers I'm talking about. So step 1, draw an x, fill in the top and the bottom. The top is a multiplied by c. The bottom is b. Now here's the hard part. Today, we do not have a first number. So today we take 1 times your last number, which is always just your last number. Now that's one of the problems. That's one of the reasons I almost start with the harder ones, because a lot of students get used to just putting the last number in that top spot, and so they end up missing it if they have a number in front. That's going to be the next lesson we do. So make sure you remember, if you just put your last number in there, that works for today, but it should be your first number times your last number. Then your b term goes to the bottom. Now, the important thing for today, if you want to set it up that way, that's preferred. But step 1 and 2 is really all we're going to need today, besides this example I'm going to do for you in a second. So the second one is you're going to try to find 2 numbers that multiply to be the top number that add up to be the bottom number. 2 numbers that multiply to be the top, add up to be the bottom. You're going to put those 2 numbers on the sides here. Now, obviously / honestly, I don't care if you set it up that way. I just like that because it's a nice, good, clean way to stay organized and to make sure you have everything in the same spot. You guys all remember I said that in Algebra 2, one of the biggest battles is just staying organized, knowing where things are at, and staying clean. That's why I like this method. So if you don't want to put your numbers on the sides here and skip that step, that's fine. I'm going to encourage you to. Last thing, again, make sure you're looking, make sure you're double checking, and make sure you're looking for your signs, your positive and negative, and we'll talk about this tip in a second if you get the wrong B. So the ones that we won't get to today, and we'll go over this all again tomorrow, is step 3 and 4, and this is the divide, slide, bottoms up part, where once you have those 2 numbers for today, you're going to be done. Those 2 numbers are going to be part of your answer. But next lesson we do, you're going to set up your answer, but then since there's a leading coefficient in our next lesson, you have to divide both of those numbers by their leading coefficient. And then your last step, you're going to either reduce those fractions or you're going to take the denominator and move it up in front of your x. So again, I'm going to show you one of these today just to kind of show you what these steps are, and then all we're going to do is focus on steps 1 and 2 for today. So, step 1, I'm going to set up an x, and the top number is going to be 2 times 15, your a times your c, so that's 30. Now, normally speaking, you guys probably won't write the 2 times 15. You'll just do it in a calculator and put 30 there. That's fine. And your bottom number is 13. So I'm looking for two numbers that multiply to be 30 and add up to be 13. Here's the deal. Most of you guys probably already know what it is. If not, do the same thing we were doing earlier. On my answer key, I did this for every single problem. Because again, I was the student that I'd be like, well, 2 and 15 don't work because you'd have to, that subtracts to be 13. That doesn't add to be 13, and I'd get really confused. So 1 and 30, 2 and 15, 3 and 10, 5 and 6. Which ones add to be 13 is the 3 and 10. So positive 3, positive 10. Now this is a great way, this is a great place to check your work. Do these two numbers actually multiply to be 30? Yep. Positive 30, good. Do these two numbers actually add up to be positive 13? Yes, so you're on the right track. That's the other reason I like this method. It's a really good way to check your work quick before you finish. So then you're going to take those numbers and you're going to put them in your parentheses. X plus 3, X plus 10. Now here's the thing. Today, we're going to be done there. Normally, if there's no number in front, that's going to be your answer. But that's the other thing where a lot of students get used to that, and so that's what they leave as their answer. If there's a number in front, you still have a couple more steps. So since we do have a number in front, we have to take that number, step 3, and divide both of them by that. If you can reduce, please do so. So 10 over 2 ends up being 5. If you can't reduce, you need to get that 2 up in front of your x. Get it out of the denominator, so you're putting it up in front of this x. So you end up with 2x plus 3. That then is your answer. Now again, this is harder than it's going to be today. So if you're still a little bit confused at these last couple steps where I divided and did that stuff, don't worry about it. We'll go over a lot more of those tomorrow. But again, I wanted to show you one example where I use all 4 steps before I start going on to the problems where we only use half of them. So again, if you're confused at that, don't worry. Before I do these other ones, another way to check your work, and there are teachers that this is how they teach you to do it, and I mean, it's okay. I would rather you pay attention to your positive and negatives. I think that's easier. But if your second sign is a plus, that means both of your signs are going to be the same. And what that means is your answers are going to look like x plus a number, x plus a number, or the opposite, x minus a number, x minus a number. The signs are going to be the same. If your second sign is a minus, then your sign is going to be different. One's going to be plus, one's going to be minus. There's other things you can tell if you actually look hard at that. I'm not going to go over them because I don't want to confuse you and throw too much at you. So with C, right away, I know both my signs are going to be the same. Both my signs are going to be the same. The other thing we know is they both have a leading coefficient of 1. There is no number in front, so that's going to make life a little bit easier. Now again, some of you will look at number 4. Maybe not today, but by the time we take the test, some of you guys are going to look at number 4 and say, oh, that's x plus 6 and x plus 2. You're absolutely right, and if you want to do that, that's fine. I can live with that. I would rather you show a little bit more work, but whatever, your prerogative. However, if you're somebody that can't just look at it and do that, and even if you can, I would encourage you to still do it the long way, because that's going to make the next lesson easier. I still am going to set up my x. 1 times 12 goes in the top. Again, normally you don't have to write that out, but I want to show you because I don't want you guys to get used to just putting the last number in. It's the first times the last. So factors of 12 that add up to be 8. 1 and 12, 2 and 6, 3 and 4. The ones that add up to be 8 are 2 and 6. So we have 2 and 6. Then we put those in our parentheses, x plus 2, x plus 6. We do not have a leading coefficient, so we are done. That's it. That's your answer. Hopefully not too bad. And if it is, hopefully when you do a couple of these, I mean, again, that's all we're doing today. So hopefully once you've done a couple, they get a little bit easier. Number 5. Now pay attention to number 5. Even if you're good at this, I want to show you guys a little thing that you have to pay attention to with number 5. And it's actually the little tip that I put up here with Step 2, if you get the wrong sign for b, change your signs. So I have 1 times 60 goes in the numerator, so I'm looking for factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, I think. And I know I went really quickly through that, but I'm hoping by this point you at least know where those numbers came from. If not, please ask. Here's the deal, though. I want factors of 60, so two numbers that multiply to be 60, but they have to add up to be negative 16. If you look over there, none of them do that. None of them add up to be negative 16. However, these two add up to be positive 16. If this ever happens, I'm looking for a negative 16, I get a positive 16, or vice versa. If you ever get the exact same number that you need, you're just off, the sign is just the opposite, all you have to do to help that is change both of your signs. So it changes to a negative 6, changes to a negative 10. That's going to change this to a negative 16. Negative 6 plus negative 10 is negative 16. Now again, I would greatly encourage you to double check your work at this point. In your calculator, type in negative 6 times negative 10. It does give you positive 60. It is a positive. Negative 6 plus negative 10 is negative 16. I would always take 2 seconds to do that because that's how you can catch a lot of your mistakes with those positives and negatives if you take the time to do that. Once you've done that, again, there's no leading coefficient, so your answer is going to be x minus 6, x minus 10. If there was a leading coefficient, we'd still have a couple more steps. Since there's not, that is your answer. Any questions on either of those? Just to stay consistent with the other classes so I don't confuse myself a lot, you guys, your class period is a little bit longer. The other classes, I did not have time to go over the you-do section with the cheat sheet number 3. I will go over this probably at the end of next lesson just to make sure we have those filled in. But I'm going to go ahead and skip to D. So D, the only difference is the second sign is minus. So now both your signs are going to be the opposite. Now again, the good news is if you pay attention to your signs, you don't have to worry at all about if your sign is a negative or positive or what that is. You don't have to worry at all about if the signs in your answer are the same or if they're opposite. But it's a good way to check your work. So we're doing this the same way. 1 times negative 90 is negative 90. One times negative 90 is negative 90. We're looking for factors of negative 90 to add up to be. A lot of people miss this. 1. A lot of people put 0 because there is nothing with your x, but if there was a 0 with your x, there wouldn't be an x at all. So there's a 1x there. So now here's the difference that makes this one a little bit more complicated. I'm not looking for factors of 90. I'm looking for factors of negative 90. Well, what's the difference? Well, the difference is instead of having 1 times 90, that does not multiply to be negative 90. That multiplies to be positive. So the only thing I change, and there's other ways to strategically do this that might help you a little bit later. I think the easiest way is to go ahead and just make your left hand negative. Now, negative 1 times positive 90 is negative 90. Negative 2 times 45 is negative 90. Negative 3 times 30 is negative 90. I don't think 4 works. Negative 5 times 18 is negative 90. Negative 6 times 15 is negative 90. 7 doesn't work, 8 doesn't work, 9 works. So negative 9 and 10. Now you might tell yourself, well, wait a minute, couldn't I put the negative with the other side? Isn't positive 1 times negative 90? Doesn't that work too? And the answer is yes, but I'm not going to do it that way. I'm always going to do the left-hand side. You can do it how you want. I'm always going to do the left-hand side. So we are looking for numbers that multiply to be negative 90. So that's what we have the list of. But they add up to be positive 1. That is your negative 9 and 10. And it doesn't matter what order you put these as well. If you put positive 10 and negative 9, that's okay too. So I'm going to give you the same answer. So we end up getting x minus 9 instead of plus. Now it's minus. And x plus 10. And that is your answer. Again, if there's a number in front, if there's a leading coefficient, then we'll go through and do a couple more steps. And this is where it gets a little bit more difficult, where I have some students that before, with the adding problems, with number C, with letter C, number 4, a lot of people knew it was 2 and 6 without doing any work. That's great. Number 5, a lot of people know it's 6 and 10. I will be honest, though, this is the most common missed question on a test, because a lot of people put 6 and 10 and they don't put negative and negative. So again, make sure you're being careful with that. But a lot of people then, they think they're really good at this, and then they get to these and they start struggling. Please, please, if you aren't good at this, or if you in any way second guess yourself, go ahead and show your work, because that's a really good way to make sure you don't miss anything. And number 7, this is another one that is a good one. One times negative 33 goes in the numerator. Negative 8 goes in the denominator. I'm looking for factors of negative 33 that add up to be negative 8. So again, it's negative. So I'm going to put negative 1, positive 33. 2 doesn't work, negative 3, and 11. Again, you could have switched some things around. That's fine. But I like to start and do the same thing every time. Now, just like before, some of you maybe notice, this does not add up to be negative 8. It adds up to be positive 8. But the same thing as before. If you're ever so close, switch both of your signs. Instead of negative 3 and positive 11, make positive 3 and negative 11. That will change that, that positive 8 into a negative 8. So, positive 3, negative 11. Now again, I don't mean to be a broken record here when I say this, but I love this X method because this is a perfect way to double check your work. 3 times negative 11 is negative 33. 3 plus negative 11 is negative 8. You would not believe how many people miss problems, and the only reason is because they didn't take the time to do that. And again, really the main reason I do that is to check my positives and negatives. It's not even to check anything else. But a lot of people miss some of those positives and negatives. So your answer ends up being x plus 3, x minus 11. Last but not least, I'm going to tell you this, and I know most of you guys won't. That's your prerogative. I like to double check my work with this because another way to double check your work is actually multiplying these out. And it's really funny because I've had people do it. Maybe some of you guys did it. Someone did. I don't know if it's in this class. I would bet out of my 100 students, at least one did this, where they get their answer, and then they don't think they're done because they start multiplying things out. If you multiply this out and distribute, you end up with the question. That's the whole idea. We're doing the opposite of multiplying. We're breaking this up. So if you multiply this out, you just go back. So you can check your work if you wanted to by distributing and making sure you end up with this answer. Again, I know a lot of you guys won't do that. That's fine. It's up to you. But this way of checking it is significantly quicker. All right. Are there any questions over those? My goal this semester is to get to stay a little bit more ahead.